Next we are having a EMF series. EMF series or electromotive force series I can say, or it is also known as SOP series or SRP series depending upon its oxidation potential or reduction potential. That is SOP, standard oxidation potential, and SRP, that is called as standard reduction potential. So we have two names, that is SOP and SRP. SOP, as I said, standard oxidation potential, and SRP, that is standard reduction potential. So we have standard oxidation potential and standard reduction potential. Now this SOP and SRP value help us to decide whether which substance is going to oxidize or which substance will reduce. Means with the help of this we come to know about the oxidation reduction. Like I said, we did that electrolysis of molten NaCl, aqueous NaCl. In aqueous NaCl I said that sodium from Na plus and H plus, the H plus have more tendency to reduce. How to know that whether H plus have more tendency or Na plus? Then we come to know about it with the help of this SOP or SRP series. The series is the same order, but if I'm saying SOP like here to here, then I will say SRP is from here to here. That means the values are just opposite to each other. If I'm saying that standard oxidation potential, it is represented by the E letter, E oxidation. E stand for potential, and if I'm writing oxidation, that means it's a oxidation potential, not means standard oxidation potential. And if I'm representing it by ERED, that is reduction potential, E naught, that is standard reduction potential. What it is, we will do in a detail later, but just for a short knowledge, I'm just saying that it's a standard oxidation potential and standard reduction potential. The values for a given metal, right? For given metal or for given element. For example, suppose if I'm saying oxidation potential of zinc is, for example, suppose a minus 0.736. It's a reduction potential of a zinc. Then its oxidation potential will be what? If it is a reduction, then oxidation potential will be same number, only the sign will change. So this will become the reduction potential. Oxidation means the values are same, only the sign changes. Now let's see what the series is. The series it is given in your book, where all the elements are arranged in the increasing or decreasing order of their element. Now I'm just telling you the shortcut to remember, or the simple way of remembering this electrochemical series. So the series is given in notes, the complete series. So how to remember it? So we have this series, that is a SOP series. I have just given the mnemonic form for this. Actually, the series is like lithium. This P stands for the potassium. It's not a phosphorus, a mnemonic form I just given. So the series is actually potassium. After lithium, the potassium comes. Then C, it's not representing a carbon. It's a calcium. Then sodium. Then we have M, that is a magnesium. It represents aluminium, zinc, chromium, cadmium, cobalt, which comes between this I and N. I stand for iron, that is Fe. N is a nickel, tin, lead. Then after that we have hydrogen, copper, silver and gold, and in between copper, silver and gold we have 3-4 halogens, that is iodine, bromine, chlorine and fluorine. So this is the SOP series. How to remember it? It's a Li, PCS, magental, then hydrogen, copper, silver and gold. Now in this case of Li, PCS, magental, hydrogen, copper, silver and gold, simply I can say that these are the metals after hydrogen. These are the metals which have a lesser tendency to reduce. For this copper, silver and gold, I can say how to remember that as we are moving on from these three, this is the cheapest one, then silver is a costly and gold is still costlier one. And then how to remember this halogen series? Then simply I will say it's a fluorine, chlorine, bromine and iodine. That means, or I can say you are moving down to top in a halogen, that is first iodine, then bromine, then chlorine and then fluorine. Okay. Now this is the SOP value. SOP decreases, it means simply I can say SRP is increasing. From lithium and magnesium, I can say I can say who have a more tendency to oxidize. And answer is that the SOP decreases. That means the lithium have more tendency to oxidize, and lithium have more tendency to oxidize. That means lithium will oxidize and the magnesium will reduce. Or from lithium and magnesium is the magnesium is having a lower tendency to oxidize, it means it have a higher tendency to reduce. So from this, when I'm talking about the electrochemistry, then many times the question comes on the application of electrochemical series. Now, what are the applications of this electrochemical series? With the help of this electrochemical series, we can easily predict what will be the electrolytic product. That means if I'm carrying out any electrolysis process, then what product will form can be predicted by using this electrochemical series. Now let's see the first application for this electrochemical series is that predicting the first one, that is a predicting electrolytic product. The example, I can say the first one, that aqueous NaCl. If I have aqueous NaCl and if the electrolysis is carried out, then what product will form can be predicted with the help of this EMF series. The first, you just decide that which type of ions will be present inside the container. In container we had taken aqueous NaCl, means NaCl is dissolved in water. Then I can say that their ions will be Na plus, Cl minus, H plus and OH minus ions. So there are total 4 ions, 2 positive and 2 negative ions. The positive ions will, being a positive, they will move toward the negative. That means they will move toward cathode, and Cl minus and OH minus will move toward anode. So now let's see what reaction is taking place on cathode and what reaction is taking place on anode. So as I said, cathode, the Na plus and H plus will move on a cathode, that is a negative electrode. Now sodium and H plus cathode, so they will undergo oxidation reaction. So from sodium and H plus, who will oxidize, they will undergo reduction reaction. Being a positive charge, they will gain electrons. So who will reduce first, sodium ion or H plus ion? So as I'm moving from left to right, the SOP decreases, it means SRP increases. So I'm talking about the reduction, so think about the SRP value. So SRP increases. Sodium H stand for sodium, and this is hydrogen whose SRP value is more, than simply I will say H plus is having higher SRP value. And if H plus is having higher SRP value, so H plus will gain electron and will form hydrogen, but hydrogen forms in H2. I'm not balancing the reaction, I'm just writing the product, because in entrance exam they generally ask the product, that which type of product, what product is forming at cathode or anode. Or if you want to balance, the 2H plus 2 electron will give you H2. Now what reaction is taking place on anode? On anode we have 2 ions like a Cl minus and OH minus ion. So here the ions has not been arranged, so we have a series for ions also. Now let's see the series for ions. I minus, then Br minus, then Cl minus, then OH minus ion, then nitrate ion, then sulfate ion, and then finally the fluorine. Fluorine is considered as the strongest oxidizing agent that have a very strong tendency to reduce, that is the highest SRP value. So fluorine will always comes at the last in a SOP series. Okay, now from Cl minus and OH minus ion. In actual series, OH minus ion oxidation potential is more than Cl minus ion oxidation potential, but due to that over voltage effect, Cl potential increases. So in series I had considered the Cl first and then OH minus ion. So anode, Cl minus ion. Cl minus ion oxidation potential is, means according to this series, Cl minus is having a higher oxidation potential, so will give you Cl plus electron, and this Cl will give you actually Cl2. Okay, so this is aqueous NaCl. Then ultimately which type of product is formed? I got H2 at cathode, Cl2 at anode. And what is left inside the solution? Then Na plus and OH minus ion. So the solution which is left inside is NaOH. So this is a product which is byproduct, I can say, which is left inside the solution. Let's see the second example for this. Suppose I have aqueous copper sulfate. And aqueous copper sulfate, we have to predict the product over here. So first decide which type of ions, what ions are present. So here the ions will be copper ion, sulfate ion, H plus ion and OH minus ion. copper ion, sulfate ion, H plus ion and OH minus ion. Now from these 4 ions, which will be have more tendency to oxidize or reduced. So let's see the reaction taking place on cathode. Cathode on cathode, negative electrode, 2 ions will come, copper and H plus. Now from copper and H plus, which have they will reduce, means I have to think about the SRP. So from SRP will increase. From copper and H plus, who have more higher SRP value, then simply I will say H plus is having a higher SRP value. And since, copper is having a higher SRP value, so copper will reduce and you will get Cu2 plus will gain 2 electron, I will get copper. So at cathode, copper is forming. At anode, which ions will form? Then again from sulfate and OH minus ion. OH oxidation potential is more, and since OH minus ion oxidation potential is more, so it will form O2 and the electron will be lost. And what is left inside the solution after the electrolysis? Copper and O2 OH minus ion is removed on the electrode, or they are deposited on the electrode. So left is H plus and SO4 2 minus. So the left substance is H2SO4. Then the third one, let's see the third example, aqueous KNO3, that is potassium nitrate. Again, if I am talking about the ions, which ions will form? So KNO3, that is I will have K plus ion, NO3 minus ion, H plus ion and OH minus ion. Again, that SOP series will tell you that from potassium and NO3 minus, which is having a more tendency to oxidize. Or let's say the cathode, which have a more tendency to reduced. So K plus, that is P, potassium is K plus, that is potassium, and H plus. H plus have a more tendency to reduced. So H plus will gain electron and will form H2, and anode, that is from NO3 and OH minus ion, then simply I will say OH minus ion have more tendency to oxidize. So H minus ion will oxidize to O2. So at cathode H2 will form, and at anode oxygen O2 will form. And what is left inside? H plus and OH minus ion is removed. So left is KNO3. So KNO3 will be left inside the mixture. This is the first application, that is predicting electrolytic product. Now let's see the second application for this. Predicting oxidizing and reducing agent. Now, what is oxidizing agent? Then simply I will say oxidizing agent is a one which have more tendency to reduce. More tendency to reduce means it undergoes reduction. And what is reducing agent? Reducing agent is a one which have a more tendency to oxidize. That means undergoes oxidation. Now, in a SOP series, when I am moving from left to right, I can say from here the more oxidation potential increases, and oxidation potential increases, that is decreases. That means SRP increases. SRP increases means more tendency to reduce, I can say. The tendency of reduction goes on increasing. And if the tendency for reduction goes on increasing, that means I can say will be consider elements will become better and better oxidizing agent, because the tendency of reduction increases. So better oxidizing agent if you are moving from left to right. And if you are moving from right to left, that means SOP will increase, and if SOP is increases, that is a more tendency to oxidize. and more tendency to oxidize, that means we'll consider as a better reducing agent. So we'll have better reducing agent. Now let's see some example, the questions which are asked on this. For example, suppose I have 3-4 ions, like I have aluminium 3 plus ion, I have magnesium, I have silver ion, and I have copper ions. Aluminium 3 plus ion, whenever it will come, it will reduce. Aluminium 3 plus will gain 3 electron, will produce aluminium. Magnesium 2 plus will gain 2 electron, will form magnesium. And if it is a silver, it will gain 1 electron and it will form silver. And if there is a copper 2 plus ion, will gain 2 electron and will form copper. The question is from all four which have a better tendency to reduce. Who have more tendency to reduce? So more tendency to reduce, and I can say simply from aluminium, magnesium, silver and copper, the better tendency to reduce is, okay, so they are undergoing reduction. So they are all undergoing reduction, means they are acting as an oxidizing agent. So I just wanted to know which is the strongest oxidizing agent from all four. So the strongest oxidizing agent will be the one which is having the highest tendency to strongest oxidizing agent will be the one which have a highest tendency to reduce. So which have a highest tendency to reduce from all four, then I can say the silver will have the highest tendency to reduce, that is SRP will be high. So the silver will act as the strongest reducing agent, oxidizing agent. After silver, it will be copper 2 plus, then I can say aluminium 3 plus, and then it is going to be magnesium 2 plus. So with the help of this SOP series, we can predict the better oxidizing and reducing agent also. Now let's see the third application of the EMF series, that is the displacement based for the displacement reaction. Displacement reaction, the example I can say, or the first one in this, the metal displacement reaction. Metal displacement reaction. In this case, I can say the metal which is having a higher tendency to oxidize can displace the metal having a low tendency to oxidize from its salt. A metal having a higher tendency to oxidize means a metal having a higher SOP value can displace a metal having a low SOP value from its salt. For example, suppose if I have a zinc plus copper sulfate, zinc plus copper sulfate, this reaction. Now in this reaction, what happens? Zinc and copper, who have here the copper is in oxidized state. So when the copper sulfate get into the contact with the metal which is having a more tendency to oxidize, then this copper get replaced or it get displaced from the salt. So zinc and copper, who have a more tendency to oxidize, and I will say zinc have a more tendency to oxidize because it have a higher SOP value. So since it have a higher SOP value, so zinc displaces copper so that we get a zinc sulfate and copper. And this is the reason that we always say that copper sulfate cannot be stored in case of in a zinc container, because if the copper sulfate is stored in a zinc container, then what will happen? All the copper ion will be displaced by the zinc, and instead of getting in a container, we will get zinc sulfate. Then another reaction I can say, suppose if I have magnesium plus PbCl2. Again here, when the magnesium is treated with the PbCl2, I can say that magnesium is having a higher tendency to oxidize. So simply the magnesium will displace lead and we will have magnesium chloride plus lead. So this is a metal displacement reaction, that is a metal having a higher tendency to oxidize can displace other metal that is having a higher SOP value can displace other. The second one is hydrogen displacement reaction. Hydrogen displacement reaction. Here the hydrogen displaces the other element. The example, here the hydrogen is displaced by the some metal. Now from hydrogen displacement reaction, here the hydrogen is getting displaced from its acid. Generally the majority of the acids are containing H plus ion. So there are the certain metal which displaces that hydrogen and produces hydrogen gas. For example, if I am treating zinc plus HCl, so question arises whether the zinc will be able to displace hydrogen or not. So first you just find out hydrogen is in which state, oxidized or reduced. Then hydrogen oxidation number is +1, that means it is in oxidized state. And hence the hydrogen can be displaced or by all those metals which have the more tendency to oxidize, that is having a higher SOP value. So hydrogen can be displaced by all these metals. The copper, silver and gold cannot displace hydrogen. So if the zinc is treated with HCl, then zinc will displace hydrogen and will get combined with the chlorine and hydrogen gas will be evolved. But at the same time, if I am treating copper with HCl, then copper do not have that much tendencies to, it doesn't have a tendency to displace this hydrogen, and hence the copper chloride will not form or hydrogen gas will not evolve. So this is hydrogen displacement reaction. Then third one we have halogen displacement reaction. Halogen displacement reaction. Example. Now, when I know that halogens, it's a fluorine, chlorine, bromine, iodine. These are something like this. And we had learned in a group 17 element that all the halogen which are present in a higher, on the upper side, can have a tendency to reduce the halogen which are present below to it. That is, halogen like fluorine can displace chlorine, bromine, and fluorine can displace chlorine, it can displace bromine, it can displace iodine. Chlorine can displace only bromine and iodine, and bromine can displace only iodine. So all the halogen which are having a higher, which are present on the upper part can displace the halogen which are present on the lower part in a given group or in a periodic table. Or I can say, halogen being a non-metallic in nature, they are always in a reduced form. So a halogen which have a more tendency to reduce means a halogen which is having a higher SRP value can displace a halogen with a lower SRP. That means fluorine SRP is more than these three, so fluorine can displace these three. Chlorine SRP is more than these two, so chlorine can displace this, but chlorine cannot displace fluorine. So example here I can say, suppose if I have KF, and if this KF is treated with bromine, or KBr I have, and this KBr is treated with chlorine, then chlorine, since it is here, so can displace bromine, so finally I will get KCl plus bromine will form. Similarly, if I have sodium chloride and it is treated with fluorine, then fluorine again have a more tendency to reduce, so it will displace chlorine, and finally I will get sodium fluoride plus I will get chlorine. So halogen displacement reaction is also possible, so here the displacement reaction can be predicted whether the metal will displace hydrogen or metal will displace other hydrogen, or have one halogen will displace other halogen or not. It can be explained on the basis of this electrochemical series. The next, that is the next application, that is fourth one, to decide the spontaneity of a reaction. To predict whether the given reaction is spontaneous or not. So to predict the spontaneity of the reaction, spontaneity, I can say that just to know, I just wanted there, suppose in an exam that some reactions will be given and the question will be from the following, which is a spontaneous reaction or which is a non-spontaneous, and the question may, suppose if it is based on the redox reaction, then how to know whether the reaction is a spontaneous or not. Here we are talking about only those reactions which are redox reactions. So let example, suppose the question is copper plus zinc sulfate. and the question is the copper sulfate and zinc is formed, and they just wanted to know whether this reaction is spontaneous or not. Now what is spontaneous? Spontaneous means a reaction which takes place by its own, and non-spontaneous means whether the reaction will take place, the reaction which do not take place by its own means requires some external help. So I just wanted to know whether this reaction is spontaneous or not. Then simply I will say just find out the oxidation number of all the metals. Here the copper is 0, +2, +2 and 0. And just find out that which metal is oxidizing. So copper +2, 0 to 2 means oxidizes, and zinc 0 to +2 to 0 means reduced. So I can say that here the copper is oxidizing and zinc is reducing. And now just compare both the metal that is copper and zinc, and just find out from electrochemical series that who have a more tendency to oxidize. So I just come to know that zinc is present here. That means zinc have a high tendency to oxidize. Its SOP value is more. So if the zinc and copper is kept together, then zinc will oxidize and copper will reduce. The zinc should oxidize and the copper will reduce. But here the exactly opposite thing is happening. The copper is oxidizing and zinc is reducing. And since the our thinking from the SOP series and the things which is given in the equation does not matches, or I can say here the process which is taking place is exactly opposite to the SOP series. That's why I can say it is a non-spontaneous process. In a series, from the series we are expecting that zinc should oxidize, but here the zinc is reducing. That since so things are in opposite. That's why it is a non-spontaneous reaction. Now let's see some more reactions. Spontaneous or not? So just find out oxidation number 0, +1, +2 and 0. Copper is undergoing oxidation and hydrogen is reducing. Again just compare it. Copper is oxidizing from copper and H. From copper and H, the SOP series that says that the copper is having higher SRP value, so copper should reduce. But here the things are getting opposed. Things are exactly different. Here the copper is reduced and oxidized, and we are the series says that copper should reduce. Means again I can say the reaction is non-spontaneous. If I'm having a reaction like zinc plus H2SO4 produces zinc sulfate plus H2. I just wanted to know whether the process is spontaneous or not. So it's +0, +2 and this is 0. Now in this case, zinc oxidizes, hydrogen has reduced. So zinc and hydrogen, so SOP value of zinc is more. So zinc should reduce, oxidize and hydrogen will reduce. The same thing is happening inside the reaction. Here also the zinc is oxidizing and hydrogen is reducing. So in this case, I can say the things are exactly like SOP series. The same thing is happening which is expected according to the SOP series. That's why I can say that this reaction is a spontaneous reaction. This reaction is also spontaneous. This is also spontaneous. This is also spontaneous. This is also spontaneous. You can determine its spontaneity by using this oxidation number method also. So these are, I can say, these are the applications of the SOP series, and these applications are very important because in exam the MCQs are many times asked from the electrochemistry. The MCQs are many times asked on the application of this EMF series, that is SOP series or SRP series you can say.